Hey folks, how are you? Listen, for this week we're going to be talking about what's called the independent t-test. But before I get into this, let me make a note that we will not be covering chapter 11, which is the dependent t-test, sometimes called the related samples t-test, sometimes called repeated measures design. Basically, again, now I'm talking about, at this point, chapter 11 on the related samples design. That kind of t-test is usually used if, for example, you're doing a pre-post test with the same group of people or you're matching groups. Typically, we use two independent samples, which is why I'm focusing on chapter 10 with the independent t-test. However, if you do need to run a dependent t-test for your practicum or anything like that, the only difference you're going to find in doing SPSS is instead of doing an independent t-test, you do a related samples t-test. So I want to focus this week on the independent t-test. And what I ask you to do this week is first read pages 280 to 88, but actually first look at figure 10.1 on page 280, because on page 280 that little figure 10.1 actually describes what we're doing with an independent t-test. And notice that there are two presumed populations and two independent samples that we are testing. Not one, but two. Secondly, after you take a look and try to get a sense of pages 280 to 288, I ask you to do the learning check on page 288, but I'm only asking you to do numbers 1, 2, and 3. However, numbers 1, 2, and 3, especially number 3, will require you to look back in the chapter to find some appropriate formulas. And as I indicate, those formulas are found on pages 285 and 287. We will be going over this in class, but I am going to ask you to do your best at sharing with us what you did, including any questions. And if you have a problem with it, that's when me, will jump in and help, okay? So don't get all flustered. Then I tell you that on pages 289 to 292, what they do there is actually demonstrate the four-step hypothesis testing that we talked about in class. And that four-step process is used for any hypothesis test. Number 4, on page, it says page 295, explain how to report results of an independent t-test using in the literature on page 295. And you'll be doing that for your SPSS report. Now, for your learning check on page 296, now this is a little more involved, and it involves basically a few steps. But if you look at, I'm asking you to actually do only number 1, not number 2. But I am asking you to do, and also only A, B, and C, not D. But even with that, there's a line of logical reasoning that you need to follow to solve that. I'll give you some brief hints, but again, we'll be doing this in class also. First of all, what you actually need to do as step 1 in hypothesis testing is set up the null hypothesis. And I would have the null hypothesis as mu1 equals mu2, the alternative hypothesis as mu1 does not equal mu2, and we're setting an alpha level of 0.05. And the critical value associated with alpha equals 0.05, if you look in the back of your book, you'll see on page 575 that if you look under a two-tailed test where there's 5% of the area in both tails with 30 degrees of freedom, because you see each sample size has 16. And so you have to subtract 1 from each sample size, so that's 15, right? 15 plus 15 is 30, which gives us 30 degrees of freedom. So look in the back of the book, and you look under the 0.05 level for two-tailed test with 30 degrees of freedom, and you'll find a critical value of 2.042, okay? So we're finding the critical value, just like if we're doing car shopping. The first thing we do is we set criteria for what we're going to accept, whether to buy a car or not. The next thing we need to do then is we need to compute S-square pooled, which is a formula that is listed on page 285, I believe. Let me check. I don't have it marked on my own solution here. It's equation 10.2 on page 285. There's a formula for S-square pooled, because remember, we're using 2 samples now, not 1. And so what we do is we compute S-square pooled, and as the answer says, you end up with 72 by using that formula. And then you compute the standard error, the difference, which is, I believe, on page 287, that's equation 10.4. Now, if you substitute numbers in equation 10.4, I get 3, which matches to what the answer is in your book. And then the third step is you compute the t statistic, your test statistic. Now, the test statistic, which is the t statistic, which is listed again on page 287. If you look the middle of the page, it says the complete formula for the independent measures t-test. I just simplify that, and I say the t-test is simply equal to the first mean, m sub 1, minus the second mean, m sub 2, divided by the standard error, the difference. So when you do that, I take m1 minus m2, which is 86 minus 82.5, divided by 3, and I end up with the t statistic of 1.17. Then we're at the stage, step 4, where we're going to compare that calculated value with our table value, or our critical value. We know the critical value was 2.042. Our test statistic is 1.17. Our test statistic is not large enough. It's not larger than our criterion value. Therefore, we fail to reject the null hypothesis of no difference, which means there's no significant difference between the two groups. Then it actually asks you to calculate Cohen's d. What you can find, the formula for Cohen d, is on page 230, and then you can look at page 232 to try to understand what that means. But I have a trick question in mind for you, which we'll talk about in class. Okay, that's it. I know this is getting into the heart of it. Please don't get frustrated and tried too much to the point that you get frustrated. It's fairly straightforward. It's just a new language. I understand it. I understand why it's difficult for students to grasp this, but we're going to do it by Jiminy. So hang in there, and I'll see you in class.